Hello guys, my name is James. I'm a physics teacher and I'm willing to teach you guys the Newton's second law. It's like the main subject of physics, especially mechanics. I'm talking about mechanics right here. So if you want to learn properly the mechanics subject, you must learn Newton's second law. That's unnegotiable, man. So F equals ma. It is how it's usually thought, but you gotta keep an eye for that R, F sub R. Why? Because it is the sum of all forces acting in this body with the mass m and the acceleration a. So it's not any force acting on the body. It is the sum of all forces, and this is a vector equation. Okay? It has a directionality. So let me explain it better. F sub r, the resultant force, it is the sum of all forces acting on this body, okay, and forces. Right? For example, I have a box, and I will push it. I'm strong as hell, my big arms, so I'm doing a real push. So F sub t, F sub j, James. The floor is not helping me because because of the frictional force. Yeah. I'll call it little f for the frictional force. So the resultant force of this problem in the horizontal axis, it is the sum of two, okay, the vector sum. So F sub r, it is F sub j, James force, plus the little f frictional force. If you establish a normal reference point, we will get in the horizontal axis F sub j minus little f. Okay, so that's the resultant force, and that's the quantity on the left hand side of the Newton's second law equation for the horizontal axis. Don't be confused. Okay. Mass is a quantity of matter. It is a fundamental unit. We will use kilograms for that and SI units. The acceleration, it is, I'm talking about the mean acceleration right here. It is how the speed varies, the velocity actually, over a given time. If in a little fraction of time the velocity varies immensely, the acceleration is also immense. On the contrary, if the velocity changes a little bit or it doesn't change, the acceleration will be small or it will be zero. So you gotta keep an eye for that change in velocity, not velocity per se. It's not that 500 kilometers per hour, like plane, has a lot of force forward. The motor can be even turned off. I am talking about the change in velocity, the change, how it changes over time, of course. Okay, so an example for you. This one. Let me read it. Teacher James is so damn strong. It is a machine. He's a power lifter. So it is exerting a push with the magnitude of 4,000 newtons, okay, 4,000. The frictional force is 500 newtons. Given that the box has 500 kilos, oh man, half a ton box. I want to know the acceleration. it is on the horizontal axis. So it is a simple problem, unidimensional. Okay? So first of all, I'll have to get my resultant force. The net force over the body is 4,000 minus 500, so it is 3,500 newtons. Second thing, given that the Newton's second law is this product, m times a, we'll solve for a. So a is f sub r over m. A is 3,500 over 500. 7 meters per second square. Like round numbers. Like easily. So it is changing its velocity in each second. It is adding to the right, my right, 7 meters per second. So 0 in the first second, 7 in the second, like 14 in the third, and so on. So yeah, this is the Newton's second law, basic explanation. Just for you guys to start really slow, but gotta keep going. Build that momentum. Any questions? Leave it down in the comments.